In session 3 here, we're going to take a look at subtraction. As in session 2 we took a look at addition, here we're going to be taking a look at subtraction. And even though later on in some future sessions we'll be taking a look at some different ways of applying addition and subtraction, at this point we're just going to focus on the way that you have been using subtraction most likely up through this point in your mathematical experience. So let's go ahead and get started here. We're going to continue on with the same type of example that we used for addition, the apples and our number line. Now for subtraction, most often the way we illustrate that or view it is that we start off with a certain number of things or a certain number of objects, and then we take away or we subtract some of those objects, and then we ask how many are left. So for example, let's take a look here at the apples. You can count them and see that there are 6 apples. So if the question started off with saying we started off with 6 apples, we removed 2, how many are left? Well, typically what you would do is you would go to your 6 apples and either erase, or in this case here we're just going to cross out. We're going to cross out what it is that we're subtracting. So the question was 6 apples, take away 2. What do we have left overall afterwards? Well, we have 4. Here are the 4 apples that are left over after we subtract. Now, one important concept at this point to recognize is that in addition, it didn't matter which sequence that we added the numbers together in. As long as the entire problem was an addition problem, you would get the same answer. For example, 7 plus 13 is the same thing as 13 plus 7. It doesn't matter which order you add them in. 5 plus 6 plus 7 is the same thing as 6 plus 5 plus 7, which is the same thing as 7 plus 6 plus 5. It doesn't matter the order. However, in subtraction, that is not true. In subtraction, for example, 10 minus 7 is not the same thing as 7 minus 10. So just remember that addition factor there of not having to determine the exact order or having to have an exact order is not the same thing with subtraction. An exact order in subtraction is necessary. Okay, there's our apple example. Let's take a look now at a number line example. Here's our starting point, and we can see that there's a hash mark representing each one of the units here on the number line, and we can see that from this starting point over to this slash here, there are 9 units. On the underside here, or on the bottom portion of the number line, I've gone ahead and broken it into 2 sections. You have this section from this point to this slash, which is 3 units, and then from the same slash over to the end here is 6 units. So we can see that this overall length of 9 has been broken into 2 lengths. The first one's 3, and the second one's 6. Now, if I were to ask you in this particular problem, what is 9 take away 3? Well, over here we crossed out apples. Over here we're not going to be crossing out anything, but we can still get some assistance by looking at the visual clues that were given here. In an addition problem, or excuse me, in a subtraction problem, when you go one number minus another, let's say in this example 9 minus this first 3, what you're going to be left with is this other section down here. So in this case, 9 minus 3 equals this 6 over here. Let's flip it around. Let's say instead, let's do a 9 minus a 6. Well, if we go 9 minus 6, what's that leave us with? Well, that leaves us with this section of 3 over here. So one of the things you may have been taught up to this point is that you can check a subtraction problem by doing addition. And to visually take a look at how that works, we use our number line here. Our overall length is 9, sublengths 3 and 6. Well, 9 minus 3 is 6, as well as 9 minus 6 is 3. And the way you double check that is 3 plus 6 equal to 9? Well, yes, it is. 9 minus 6 equals 3, so that 3 plus 6 equals 9. So for every subtraction problem that you have, you can do a corresponding addition problem to check the accuracy to see if your answer is correct. So there is definitely a relationship between addition and subtraction. Let's take a look at our next screen here. We're going to go ahead once again with the number line a little bit further. Here's our number line. I didn't bother making all 18 slashes here, but we're still going to go ahead and use the red line anyway. And we can see here that the length of this red line from beginning to end is 18 units. If we come underneath it, we can see that our first length here is 13 and our second length is x. So if I were to ask you, what is 18 minus 13 equal, as far as literally from this example, 18 minus 13 equals x. Well, if I asked you from this same example, what does 18 minus x have to equal? Well, the 18 minus the x has to equal this 13. Remember, the letter x here is a variable and it represents an unknown number. Well, in this particular example here, we can figure out what x is doing some simple subtraction. 18 minus 13 is going to be what x equals. Well, what is 18 minus 13? Well, 18 minus 13 is 5. So x down here is 5. We figured out what x is. And how can we check ourselves? Well, we check ourselves by adding. So we take this value of 5 here, which is this length here now, and we add it to this other length over here, 5 plus 13. Does 5 plus 13 equal 18? Yes, it does. So we double check that our answer here to this subtraction problem is correct by going through and adding our answer to this number here to see if it equals this. Similar example over here. You have a number line, the overall length is 27. 27 minus x equals what? It equals this 11 over here. Because remember, these two lengths combined equal this overall length. 27 minus x equals 11. Do it the other way. What does 27 minus 11 equal? Well, 27 minus 11 equals x. Now, my question to you is, what is x? Well, you can figure it out simply by a subtraction problem. We know that this 27 minus the 11 is going to be x. Well, what is 27 minus 11? It's 16. So we know that in this illustration here, x equals 16. Well, how can we double check to see if that's an accurate answer? We double check by taking our answer and adding it to what we subtracted. Well, what we subtracted was 11. Does 16 plus 11 equal the 27 that we started with? Yes, it does. So we used our addition here to double check the accuracy of our subtraction problem. Okay, let's move on quickly then to our review and we'll be finished with session 3. First of all, a definition for difference. The answer to a subtraction problem is called the difference. So if you get a story problem and it says, what's the difference between a couple numbers? It should automatically remind you that this has to be a subtraction problem. Lastly here, when we talk about the difference between two numbers, we need to subtract the second number from the first number. So for example, what's the difference between 11 and 8? Well, my first number is 11, my second number is 8. So I need to take my second number and subtract it from my first. So that would be 11 minus 8. What's the difference between 11 and 8? The difference between 11 and 8 is 3, because 11 minus 8 is 3. What's the difference between 25 and 21? Well, the difference between 25 and 21 is 25 minus 21, which is 4. So just remember that when you have a couple numbers and it's asking you for the difference between the two, that you need to subtract the second number from the first number. Okay, that finishes session 3.